Well, good evening. My name is Doug. I'm coming to you tonight from Emerald Hill Skies on the outskirts of Louisville, Kentucky. We are getting started with this live stream tonight to tackle objects in the Caldwell List. It's been some time since we were tackling the Caldwell List. We've been caught up in the Herschel 400 for a while. But the way these objects are set up, they rotate with the sky throughout the seasons of the year, and there are some constellations that are summer and some that are fall, some that are winter. And if the sun is up when that season's constellations happen to be up, then we just have to wait for a while until that season rotates around. And that's what we've been doing with the Caldwell List. And so we have now 13 objects that we're ready to tackle tonight. Let's go ahead and get started. If you are observing tonight, we would love it if you would maybe log on to the live stream and let us know you are there. I'm just going to check into the live stream here if I can and make sure our audio is good. Here we are. Make sure that we've got audio working here. Okay. I think that our audio is going. So we'd love it if you would log on and let us know if you are observing. Let us know your location, and we'll look forward to finding out where you're from. So let's get started tonight. Let me see. We are gonna, get this screen out of the way, and we're looking at this sky tonight. That's our sky cam. Pretty clear so far. I think we should be clear till around midnight. Let's see. We're using this telescope, a RASA 11, a Roe Ackerman Schmidt astrograph. Let's come to this screen and let's set up our title just to get started here. This is going to be the NGC 6992, the Eastern Veil Nebula, Lord willing. And that's a supernova. A supernova remnant. Okay, let's come back up to the screen here, and let's slew to that. See, we're going to hook up our telescope here. Telescope control connect, and then we're going to slew to the Eastern Veil. And there you can watch the scope as it slews. I'm going to put NGC 6992 in the title of our sharp cap. You can see the weights over there on the right and the scope pointed up. And let's come back to the screen here and let me try this new, let's just do this. Let's connect the scope, and let's go ahead and plate solve manually here this time. And you remember what plate solving is. That's when we compare the expected view through the scope with plates, photographic plates, so to speak. That's the old-fashioned term. And we compare them, and if they're not quite right, as was the case in this situation, since it's our first object to move to, it was 3.3 degrees off, and this ends up synchronizing the mount with the sky. So since it was the first object of the night, there's going to be a little bit of an offset. Looks like we've settled down now, so we're going to start imaging here. Just change it manually in this case, 20 seconds, and reduce our gain to something like 200. And then let our first image come in. I see we have about 7 on the live stream. If you wouldn't mind telling us where you're watching from, that would be great. We're observing kind of simultaneously here. So it'd be great to know where you're logging on from. I had put a message here shoo, what could possibly go wrong? Because this was a rough night in the startup. I don't know why, but with electronically assisted astronomy, there are several components that have to be juggled. And then when you add to that trying to stream electronically assisted astronomy, it just increases exponentially the number of pieces. And then when you try to do that remotely, like I am tonight inside of my office, and the observatory is out, see, it's outside there. It's a roll-off roof observatory. There you see it's about 200 feet away. And at the bottom of the observatory, there is a rig rack that converts the data from the cameras to fiber optic cable. And the cameras are led by this ZWO ASI2600MC Pro, which is mounted on an Octopi-Astro camera interface that connects it to the corrector plate, that glass plate you see on the business end of the RASA. So it's on that end that's covered with a black dew shield there. Tonight, for some reason, this camera would not begin communicating with us indoors. And boy, we were until probably 5 minutes before the live stream before we could get things working. So a little bit of a difficult night, but finally in the end, by God's grace, we kept changing enough connections and rebooting and restarting that the USB 3 data finally started coming in from that camera. Well, tonight let's do a quick little color balance here, a white balance. And I see, Chris, you're on from Minnesota. Good to have you there. Let's move our black threshold over to here, and let's move our mids up, and then let's start zooming in a bit. You can see the eastern veil forming up there. This looks like a hydrogen 2, hydrogen alpha. It's a supernova remnant, something left over from the explosion of a previous star. This is a beautiful object. Let's go to Stephen James O'Meara's book, Steve O'Meara's book called The Caldwell Objects, and let's see if we can read about this object. This is Caldwell 33, I guess, Caldwell 33, and the way he set these up, the eastern segment, yeah, that's what we're looking at right now, 6995 and 6992. Now this part over here, the part you see right here, there's some oxygen in there too. That's the 6995 section. And then the part that you see over here is the 6992 segment. But they're kind of both called the Eastern Veil. That's with 3 minutes, and it's kind of amazing, isn't it, that we can make out that much detail after just 3 minutes of integration. Look at those tendrils starting to show up here. There's a lot of beauty there to see, isn't there? It's a great object to start out with. See, O'Meara writes that this was discovered by Herschel on September 5th, 1784. Let's see. And he wrote that it was divided into several streams, uniting again towards the south. And then about the 6992 region, he wrote that it was faint, extremely large, extremely extended, extremely irregular, bifurcated, divided in half. And then he writes, about 15,000 years ago, an unknown star died spectacularly in Cygnus. The event, a Type II supernova explosion, would have briefly dominated the night sky on Earth. And he says if prehistoric peoples were in the habit of gazing toward the heavens for meaning, they might have found it in the sudden appearance of this new star, which could have rivaled the full moon in brilliance and remained visible for weeks in broad daylight. Maybe they wrote it on their cave walls. But this is what has been discovered, the remnant of the powerful blast, what you're looking at right now. Popularly known as the Veiled Nebula, sometimes called NGC 6992 and NGC 6995 in this eastern side, it constitutes the corpse of a single supergiant star that perished in a supernova explosion. And he says more than 100 of these corpses are known. Doubtless many others await discovery. We're at 5 minutes of integration. Let's see, he says it's also known as the Cygnus loop. When you take it collectively together, the entire wreath-like complex is an illusion of sorts. Its various pieces are parts of an expanding shell of dimly glowing gas measuring 6 moons, 6 moon diameters in our night sky, about 80 light years in space. It appears loop-like in part because we see more gas in a given square arc minute of sky when we look at the shell's edges than when we gaze through its middle. A photograph of the veil seems to tell a simple yet haunting tale, one that has been echoed over and over again since time immemorial, that life, even for things cosmological, ends in death. Of course, if you're a believer in Jesus, then you would think that this is a metaphor that death can be brought back to life through objects like this. And certainly we're seeing a lot of these red segments here. That would be the hydrogen gas illuminated. And then I don't have strong color vision, but even I can see these green segments here. And the green would be oxygen being brought to life. This is an amazing object, isn't it? Let's zoom out just a little bit to make sure that we're seeing the whole piece of the sky. There's a lot to see there, isn't there? Look how rich of a star field this is. A little bit now showing up right here, just a little bit of nebulosity. This is one of the most exciting objects that I ever remember seeing. I find it hard to believe that we've never imaged this before, so surely we had imaged it and I just failed to make notes about it. Jeff, good to have you on. Driving across Nevada on your way home to California. That's amazing. Thanks for listening in. We're going to bring these mids up just a little bit more in hopes of seeing as much as we can. I think I've worked it out time-wise that we can spend up to 9 minutes on this object. This has got to be the best object, one of the best objects we've ever seen here, Emerald Hill Skies. O'Meara goes on to explain that when a supergiant essentially runs out of fuel, then the energy that is no longer being released, so the outward pressure that supported the star stops, and a lot of the material just flies out into space, but the gravity sucks in all the fuel that's left, and then it explodes. It goes down to a star that's just 10 kilometers across, and then it just explodes. It's a cataclysmic explosion. It outshines the light of 1 billion suns, the luminosity of a small galaxy, hurls all these gases outward, and it continues to expand until it fully dissipates. All of these heavy elements like gold and silver and calcium, amazing stuff. Quite a write-up on the Eastern Veil. O'Meara says he could never quite see it through the 9-inch refractor at Harvard, but then in the dark sky, he could see it even through binoculars. It's amazing. So there's quite a bit of write-up, quite a bit of extra material there. I think we'll just make an observation here, and I'll bring this little observing panel over, and we'll click on observations, and we'll say, oh, and I need to add this session, don't I? Add a new session, and we'll say that it's going to end on the 19th at, let's say, 01 a.m. 01 a.m. something like that. And this is session 86, I think. I'll have to check that later to be sure. And I'll say the Eastern Veil has to be one of the most amazing objects we've ever imaged here at Emerald Hill Skies. The H alpha and O2 gases were being lit up like fireworks in the night sky above Emerald Hills tonight. This supernova left behind an amazing legacy. It did not die in vain. Isn't that something? And through this one single explosion, it left behind this amazing image that we are now able to enjoy. Otherwise, it would have just looked like a star in the sky. But now, with this amazing set of gases, wow, look at all that detail. In this rich star field, too. I think the stars, the millions and millions of stars we can see, just accent it more. Can you make out in YouTube this very light bit of hydrogen alpha up here? And look at these tendrils reaching way up here, reaching way out into space. Look at the way these are swirling out, just like spiraling. All right, 11 minutes, we're over budget here. Save exactly a scene. It's a beautiful object, though. It's hard to leave this one, but we're going to make ourselves. So now we go up here into sequencer and we say next target. And this waits for us to put in the next target name now, and that's going to be NGC 6995. I think 6995, we were already looking at it, weren't we? Yeah, we were looking at 6992 and 6995. So we're just going to make another observation here and say that, let me get this straight, 6995 is the section that we were looking at that was over with those tendrils reaching out. This was the tendrils extended section of the Eastern Veil. Same view as the 6992 segment. So it's kind of a 2-for-1 special there. So this next object will be actually, let's go to, why don't we go to NGC 42? Let's make sure this is at a suitable altitude. I'm going to have to pull out this window a little higher to see. Yeah, it's at 28 degrees. I wonder if this, yeah, let's go to this 4236 first. So let's slew to that. It's 4236. NGC 4236. And down here in the title, the scope is still turning there, isn't it? Making its way to NGC 4236. See how it's changing over to view toward the northwest, and the little camera on the back of the scope. Hey Jen, good to have you on. Welcome back. Tommy, good to have you. Good to have you here, Tommy. So we're looking toward the northwest. Let's put this title in. This is NGC, what did we say again here? 4236, a galaxy in, I think it's in Draco. Draco, does that sound right? We'll correct that in a minute if that's not right. So now this is a new part of the programming that I hadn't done before. Now we've changed our sequencing programming so that it automatically does the plate solve for us. And as soon as it plate solves, it will then change the exposure and begin. So it prompted us for the file name so that I won't forget to do that. It did plate solve. Now it's waiting and taking the first exposure. I hope we allowed enough time for the rig to settle. We're going to see if I did. This is brand new programming. Phoebe, good to have you here. Etienne, good to have you here as well. I think you're from up in Canada, if I remember right. Maybe Quebec. Welcome. Boy, that is a bright part of the sky. We're going to have to color balance again here. This is where all that light pollution is. We don't have a moon tonight, but boy, we've sure got Louisville light pollution, don't we? Looks like we were not totally settled. I think I'm going to stop this live stacking and restart it because we had not completely settled. Also, look at the blue star that's right there, or else that's maybe a pixel that's maybe having trouble. We're at our correct exposure. Do you think that's our galaxy right there in the middle? Let's use our live stacking is paused, it says. Resume. There we go. A little bit of oval stars there. I wonder if I should clear that. Make it start again. Let's start with a fresh, and on our programming, I'm going to put a little more time. Let's edit this programming. Here where it says wait 5 seconds, I think that should be 10 seconds. And let's save that. Let's see. How do we save this? Here we go. Because that did not wait long enough that time. Here we go. Now that's at 89%. Let's look at our deep sky image annotation. There we go. There's NGC 4236. I'm not seeing a galaxy there, are you? Maybe our deep sky annotation is off a little bit. Let's read about this object, see what it's supposed to be. C3. Phoebe is in Alberta. Nice to have you here, Phoebe. Etienne is in Quebec, yes, near Mount Tremblant. And John is in Magdalena, New Mexico. Good to have you here, John. Clear there in Alberta. Nice. Stu, good to have you back from New Zealand. Stu, we're on the Caldwell List tonight. And wow, this object, very faint it says. But wow, I'm not seeing it yet. I need a kind of a bookmark here. What can I use as a bookmark? I'm on a quest to find a bookmark. Here we go. I'm just going to grab this piece of paper and not really seeing this object yet. Let's back off here. That's where it's supposed to be, but I sure don't see it down there either. Normally, when we do a plate solve, we end up with our object directly in the middle of the frame, but we're not seeing anything there tonight, are we? Let's bump up these mids a little more and see if We do not have the right dark. Oh, there is something beginning to show up there in the middle, isn't there? It is very faint though. Let's go over here and look at our darks because, let's see, 20 seconds at 200. Let's find the dark we're supposed to have here. Let's see, 20 seconds. 20 seconds. 30 seconds. This is supposed to all be automatic. This was done on August 31st. Why does it not say? Let's go with this dark right here. So we'll get rid of those funny pixels in the next screen. The next picture we take. Boy, there's that phantom galaxy right there, isn't it? It's barely more than a ghostly glow right now, huh? This is so faint. Let's give that a couple more minutes, and while it's... Iggy, good to have you on from Boston. Let's see, in long exposure photographs, it's a fantastic object, almost a visual enigma. Blotchy patches of star formation pepper the arms. It is barred, has a bar across the middle like the Milky Way. Few of the details can be seen at the eyepiece. If you do see it, it's ill-defined. I've never seen a galaxy look so supernaturally faint. What happened to it here? I think our color balance became off here. It is definitely supernaturally faint. Another problem is it is down in the sky glow of Louisville light pollution for us, but it's quite large and elongated, but you need a very dark sky, pristine dark skies, in fact. It virtually vanishes if you look straight at it through the eyepiece. Huh. That's fascinating. It is a phantom galaxy. So we're just going to say in the observation here, we could see the phantom glow of this galaxy barely, but it indeed is a super faint object. It was a bit lost in the Louisville light dome, I fear. Let's do our best to pull it in the best we can. We're at 6 minutes, so we'll just get whatever of it that we can. Let's do one more color balance. That's a good color balance. Oh, now we're starting to make out a few of those stars in the arms. Look at that. This is deserving of some more integration. But thanks to electronically assisted astronomy, even in this light pollution, we're at least starting to make it out here, barely. I hope you're seeing it where you are. See, the JWST is releasing an amazing picture of the Orion Nebula. Is it visible tonight? I don't think the Orion would be here yet, but let's check it out. Steve Ramirez, to call it faint means most of us mere mortals won't see anything. That's right, Stu. Maybe a little early for Orion in the US, right? Okay, we're going to call this. Look at the way we're starting to see some of the stars that are being birthed in those arms. Mike, good to have you aboard from your dark skies out in Death Valley. going to save a snapshot of this, and we're going to try this new programming again, next target, and see if it does a little better this time. All right, let's head to the Helix Nebula, slew to it, and this is NGC 7293. NGC 7293. And we'll also put that. The scope is still moving there. You can see it's heading over toward the northeast now. When the weights are on the right, see how the scope cam looks kind of over the shoulder of the scope whenever it's viewing the North Star. So our angle, looking past the scope, is supposed to see the North Star. So this is almost, I guess, what would that be? That would look like it's almost due east, wouldn't it? Okay, let's change this title to the NGC 7293, the Helix Nebula, a planetary nebula in Aquarius. Is that where this is? Aquarius. Aquarius. Okay, back on the screen. Now I think when we hit OK, it's supposed to do a plate solve. Etienne, good thing I'm looking on my 58-inch. Are you looking through a 58-inch telescope? What? That would be amazing to have a 58-inch telescope. Uh-oh. I wonder if 10 seconds is going to be long enough after a plate solve. Man, that was close. We might have to go 20 seconds. Let's edit this sequence and allow a little more time after that plate solve, because I could still see it looked like those stars were moving. Let's see what this first image looks like. Yup, they were still moving. So let's stop the live stacking and then restart it. And then let's go up here under this programming and let's change that here. When we have wait for 10, let's bump that up to 20. Well, it's 10 seconds among friends, right? Save that. And then the next object, we'll try this one out again. Okay, that's really zoomed in tight. Okay, let's do a color balance. Pier-Tech, good to see you. The Helix Nebula has sometimes been referred to as the Eye of God in pop culture, as well as the Eye of Sauron. Pier-Tech, week 7 of clouds here. Pier-Tech, I am so sorry. Pier-Tech, we are so happy you're here. I just wish that you were able to have clear skies where you are so we could team up. Yeah, Jen's right. It has been definitely rainy and cloudy in Florida. Okay, so this eye is starting to appear there. Man, that's amazing, isn't it? This is at just 37%, so this is a huge planetary nebula. That's about 87%. I'll resume. This should, see all that grain, that should start clearing up now as we live stack additional images. I've shared with you guys before, live stacking is kind of like averaging out the light in successive time exposure frames. We do 20-second frames at a gain of 200. Stu says this object is one of the closest to the Earth of all the bright planetary nebulae. The distance measured by the Gaia mission is just, and I say just, 655 light years. What is a light year? 6 trillion miles, so it's still really a long ways away. But compared to things like, objects that we see that are millions of miles away, 655 light years is, comparatively speaking, just like round the corner. We've talked about what planetary nebulae are. They have very little to do with planets except for early astronomers like, the Herschels and others. These things at least began looking like disk shapes. And so because they looked like disks, at least that meant that the early astronomers thought of them as they have to have something to do with planets, What they really are, as I understand it, is that a star in the middle, and I don't know if this star here in the middle that we see, I don't know if that star is the central star of the Helix Nebula or not. But a star in the middle begins fizzling out, and when it does, you can imagine, since it's not as powerful as it was, it's not able to keep its outer layers intact. So they begin being jettisoned off. And as they're, just sort of fizzing out toward the sky, the star then collapses down to become almost what we would typically get called a white dwarf. So this one in the middle might actually be the central star of this planetary nebula. And when it collapses down, it begins lighting up again, and then it backlights all of the material that was jettisoned out. And especially if there is soot and some hydrogen atoms in that material that's jettisoned out, you get this effect of this reddish neon glow, and it's mixed with this soot. And then you combine the fact that that white dwarf still has a magnetic field. Even though it's a smaller star, it has a north and south pole, just like our planet has a north and south pole. And those objects that are ionizing have a magnetic field too. So they are attracted or repelled, depending on their polarity, just like a magnet is. And when that happens, it creates a north and a south pole in this backlit arrangement of plasma out there. All that ionization of that gas that's happening, it also creates a north and south pole. Now, in an object like this, you could very well imagine that perhaps this was perhaps a double star, maybe a binary star of some kind, because look, it almost looks like there is a ring here and another ring over here. So you get this kind of doubled effect. And there are several planetary nebula with this. We're probably viewing this planetary nebula from one of its poles, and so we're kind of, as it were, looking down the barrel. This is a barrel shape of gas. So if you can sort of imagine that we're in one of those, like the North Pole side of the star, and we're looking down toward the South Pole side of the star, and this barrel shape of gases are being lit up by that middle white dwarf. And I don't know, this star that we're pointing to here in the middle, this star could actually be a star that happens to be in front of the Helix Nebula just as we view it. So it could really just be a visual center star. But it's that kind of a thing that is lighting up the Helix Nebula and makes for a great little firework for us to see. Stu has added that it's expanding at 31 kilometers per second, which, what is that? 31 kilometers per second. That's not very fast, is it? When you, I don't think, right? Because isn't the speed of sound alone, isn't that, oh, that's maybe 1,100 kilometers per hour, maybe. So maybe this is faster than I think. But anyway, it's 2.5 light years across now in its current shape. And Pier-Tech says, love the helix. Phoebe says, wow. This is a beautiful object. We've been out on the Herschel list for so long, which are these exotic, obscure, difficult, tiny, faint objects, that it's almost, I think, therapeutic for us to go back and see something big. This is at 100% of the RASA plus the ZWO ASI2600MC Pro. It's at 100% of its combined APS-C imaging sensor. So in other words, we're not digitally zoomed in at all. This is just raw, real live pixels, and look how big this thing is. It's huge. Look how some of the gases are just bright neon red, and others are blackened either with soot blocking its way or just maybe that double ring effect from a binary type star. Who knows? Some people with good color vision might see some greens here. Are you able to see any of the greens where you're observing from, gang? So Pier-Tech, that is at APS-C raw 100% optical zoom. If we back off to the full frame, that's the full APS-C frame. That's beautiful in and of itself, isn't it? I kind of like this close-up view for a change. All right, we're at 7 minutes, and really that's kind of what we had budgeted tonight per object. So let's take our last shot of the helix, and then let's try our new programming here that we just did. Next target, and then let's write here about the helix. Wow, at 100%, this is a beautiful, full-framed, how do you spell beautiful? A beautiful, full-framed object. We could see bright reds, softer reds, and even greens. Could clearly see a central star. Stu told us it was 2.5 light years across, and I think you said, Stu, 655 light years from our solar system. Pretty amazing. All right, our next object is going to be NGC 7479. NGC 7479. There goes the RASA zooming in on it. NGC 7479, and this is a galaxy in Pegasus. NGC 7479. A galaxy in Pegasus. Back to the screen. And then we're going to finish our title. Phoebe, it's great that you enjoy this stuff. Phoebe's saying beautiful. Pier-Tech says yes, so much more visually stimulating than those faint, tiny objects we've been seeing on the Herschel list. What we're trying to do now is plate solve this to make sure we're right in the middle of it. And after we capture that image, it was 0.23 degrees off, by the way. Notice how the scope is settling in. So now we've allowed 20 seconds. Yeah, now see, now we've settled in, and our 20 seconds are just beginning to expire. Now we start our exposure. So that timing is much better. I like this because now we can run with just one sequence. And this one sequence does everything for us. Cued us for the title, does the plate solve, waits for the result of the plate solve, synchronizes the scope, moves to the correct position, and right there in the middle, we're already starting to see this object. Let's do, actually, we've included the first color balance. Wow, this is a cool looking object. Look at that whirligig shape. Of course, it's super grainy so far, isn't it? But some of that grain will clear up. This is Caldwell 44. I really like the way this Caldwell book works. I'll just show you here. In Caldwell book, O'Meara has put the, or the Cambridge Press, has put the objects up here at the top in big, bright, reverse lettering, really easy to read at the scope, and giant font, which just screams out at you. I like this so much better than the printing we did, where we saw with the Herschel, that we're seeing with the Herschel list. Again, this is C44, and it looks like he's grouped 43 and 44 together. How about that? I hope we can get both. 44 is a barred spiral. It's 106 million light years away. Oh yeah, Stu says 105 million in his research. It's about 4 arc minutes long. Reasonably bright in the great square of Pegasus, grand and conspicuous. Yes, it has these amazing whirligig arms, doesn't it? It's quite a bit smaller than the Helix Nebula where we just were. We're at 150%, so we're somewhat into our digital zoom, so to speak. It let's see. Deep sky observers. Lies. Explains how to find it. Doesn't say a lot about it. 7479. Unless I'm just not seeing it. Oh, here we go. He says asymmetrical. See how it's kind of mixed up a little bit? It's 100 million-ish light years away. Shines nearly the same brightness. Quite large intrinsically. Total mass of 230 billion suns. B as in Bravo, billion suns. This one is looking pretty much face on to us. The westward curling arm appears sharply defined, whereas the other arm is a little bit softer. It might have been tidally disturbed, T-I-D-A-L-L-Y, like a tide coming in at, a beach. Maybe a smaller satellite system merged with it. And that's why the one bar is longer. The little satellite galaxy just ripped through the bar. You can even possibly see dissection marks. And you see feathery extensions of dust and gas trickling off. Concentric regions of star formation on either side of the bar. It's a fine sight, but you have to be patient. And a smaller scope, it might just look like a poorly erased pencil mark. Looks like a white robed figure approaching through a fog. In moments of fine seeing, you might be able to see it transform magically from a spindle of light to a pale cat's eye with a bright vertical slit. In a 6-inch refractor, it looks like it's under clockwork motion. In a 20-foot reflector, Herschel could only say that it was a streak tapered at each end. Immanuel Kant, nebulous stars, fine structure, tiny core, supernovas have been found here. It's beautiful. The asymmetrical arms, the intense star formation are attributed to its merger with a smaller galaxy. So we're at 6 minutes now. Let's do our observation. Let's see. This barred spiral has a well-defined core, bright, and has been tidally disturbed by presumably a merger. It looks like a warped whirligig. NGC 7479. It's a beautiful little barred spiral, isn't it? It's like a backward letter S. That's 267%. That lets us see a little bit of this throwback of this arm, but it's a little bit too much pixelation, isn't it? A backward letter S. Okay, we're saving this as seen. It's a beautiful, beautiful little barred spiral. All right, our next object is the blue snowball. This is Caldwell 22 or NGC 7662. NGC 7662, and let's put it here on the title text. NGC 7662, a planetary nebula in Andromeda. So apparently the M31 is not the only object in Andromeda. This is Caldwell 22. Caldwell 22. I love this sequence because this thing kind of runs itself now. Oh yeah, look, it squared it right there in the middle. Starts the longer exposure for us as soon as the wait is done. It's waiting the 20 seconds for the scope to settle. And now it's starting the 20-second exposure. Caldwell 22 is a bright, double-shelled planetary nebula with a mysterious central star. The nebula's core is so condensed that city observers with 7x35 binoculars have spied it as a star shining just 25 arc-minutes southwest of 5th magnitude, 13 Andromedae. It's a little bit too close, isn't it, for the first image? Look at that, it does the first white balance, and it sets the black level for us and sets the mids for us. I mean, This is like amazing sequence here that's working well. I'm loving this. It's long been known as the Blue Snowball Nebula. Veteran Sky and Telescope editor Dennis DeCicco has credited Leland Copeland with originating this nickname, looking like a light blue snowball, and that was in the February 1960 issue. The key here is that the words blue snowball don't have quotation marks, and the first letter in each word is not capitalized. DeCicco stresses, Copeland was just describing the object in his own words. Interestingly, Copeland's important qualifier, the word light blue, has subsequently been dropped in the decades that have passed since he drew attention to the nebula's curious color. Without the qualifier, one expects to see a remarkably blue color, but that just really isn't there. It's slightly bluish, perhaps. Faintly blue. Planetary nebula shines when its diffuse gases fluoresce after being energized by strong ultraviolet radiation from its hot central star. That star's extremely high surface temperature can be anywhere from 30,000 to several 100,000 degrees Kelvin. And we think NGC 7662's central star has a surface temperature of 75,000 Kelvin. This one is dominated by ionized oxygen and maybe some greenish or blue-green. So in a giant telescope, you can see some blue-greens. But some would argue that it really doesn't show that much color. It's one of many imaged by the Hubble. Has an ellipse. Central star is enigmatic, might be variable. It's hard to see the central star. Its donut is glazed over with a sheen of light. You do get the central star in close-up photographs, but it has to be a large scope. This is the dawning of the age of Andromeda. Age of Andromeda. Looks very yellow in the Hubble image. Ray, good to have you here. Stu says the usual suspects are here again. Hi, Ray. All right, let's zoom in on this and see what we can see. Boy, it's just a little bit overexposed for us, isn't it? I wonder if we can darken it a little by moving our blacks over a little. It's amazing how bright it is. I tell you what, let's save this as seen. But let's reduce this exposure to maybe 10 seconds and see what we see. Boy, it's so bright. Let's back our gain down to 100 and drop this down to 5 seconds. To another color balance with that. Still too bright. 1 second. The blue snowball is very bright. Let's stop live stacking. And go with 5 seconds. How about that? Yes. Let's go with 10 seconds without live stacking. You actually see a hint of the central star there. See that little outward ring now? Now what would happen if we live stack at 10 seconds? Get rid of that bright picture. We're changing to 10 seconds. Let's clear our stack. Just too much light there from this bright guy. Still too much. Maybe we can color balance this and do a little better. This thing is so bright. I think it's bluish green, don't you? Reduced to 3 seconds. Let's clear and start again. Just experimenting with this for a second. There we go. Now we're cooking. That's 1 second exposures. Now, see the center star ever so tiny in the middle. Crazy. Okay, at least it's live stacking correctly now, but well, I'm going to, in our observation here, I'm going to say this blue snowball is so crazy bright, it's hard to isolate the center star. We finally imaged at 2 seconds at a gain of 100 live stacking, and could barely see the central point. Greenish blue, if at all, mostly green. I find this to be a challenging object. How about you guys? Very challenging, but interesting nonetheless, huh? Interesting nonetheless. All right, that's the blue snowball. Let's head to the next target. We'll do a quick refresh here. And let's go to Caldwell 17, which is NGC 147. NGC 147. Which is a galaxy in Cassiopeia. Okay, that's now it's going to live stack there. ASRAY, we've already heard from Pier-Tech that it's not good. C17, the weather is not good in Pier-Tech land. C17 and 18. Rats, I wonder if we can see both in this one frame. There it goes trying to center on C17. It's supposed to be an elliptical galaxy. We're really zoomed in, 214%. Waiting now for the first image. Might be seeing something there in the middle. Yes. Something right there in the middle. Just starting to form. Kind of a faint glow. A very large, irregularly round, faint, 4 arc minutes wide, loses itself insensibly. It's just basically a star in the center of a very faint, very large, irregularly round glow. Just faint glow. C17, NGC 147. A dwarf spheroidal galaxy, Stu says. About 2.5 million light years away, it forms a physical pair with the nearby galaxy NGC 185. We'll see if we caught that in the same frame. Right now, we'll say this was a faint dwarf spheroidal glow galaxy. 2.58 million light years away, according to our research specialist, Stu. All right, so that was NGC 147. Now, while we're watching, let's see if we happen to catch 185. We did not. Notice how this circle is just a little bit off from the real circle. Right here is where that glow is. Boy, it is centered on that star. I don't know if that star has anything to do with it or not, but you know, you have to wonder, is that glow formed partly by nebulosity? Stu says, you mean the know-it-all Wikipedia copier? Is that glow caused by nebulosity, or are those really a million stars and we just can't resolve them because of, I don't know, the size of them or the distance or something? That's 3 minutes. Tell you what, let's save that as seen, and let's look at the next object, which is NGC 185. Jen said that was stunning. So you felt like that NGC 147, Caldwell 17 was stunning, that faint glow? Or you mean stunning to think that those might be thousands or hundreds of thousands of suns? See how the amount moved just a little bit and those stars become like doubled up, and just now barely they've settled down. So we've got our timing about right, because our sequence just now moved to start capturing the first time exposure. So I think our sequence is working well. I love this combined sequence, so we no longer have to do next target, start imaging, next target, start imaging. Remember in the past, we would have to do our own plate solve command, and now this is all just a sequence for us. Boy, this 18 is also an elliptical galaxy. Jen says all those suns. Yeah, that would be amazing. This is NGC 185 now. So let's change our title. NGC 185. And this is the same. Also a galaxy in Cassiopeia. That's still the same. So did we not slew? Guess we didn't, huh? Sorry about that. I did this once last time. Slew to 185. There's 185. Billions of them, Stu says, in that glow. So Steve O'Meara says, although these galaxies reside inside the classification of Cassiopeia, they are in fact gravitationally bound to the great Andromeda galaxy. He says the speed and location and direction are about the same. And he draws them just as these faint ovals So NGC 147 is another companion, kind of like, for example, what is it? M110. Well, this is showing up a lot better. Look at that. Right there in the middle. So Andromeda Galaxy M31, oh yeah, that's what Stu's saying. NGC 185 is a satellite of Andromeda Galaxy. It's a dwarf spheroidal galaxy located 2.08 million light years from Earth. What do we need with Steve O'Meara when we've got Stu? You know? So I'm going to say satellite of M31. It's a dwarf spheroidal galaxy. Jim laughed at that. 2.08 million light years away, according to Stu. Stu, you're just really, you're going to have to work at the docent of an observatory. Is there such a thing as a docent? Look at this, man. Man, it's beautiful, isn't it? It almost looks like a globular cluster in a way. But look at those bright stars that are presumably in its orbit. As that grain settles down, as our stacked images eliminate some of that dirty grain, we should see more and more real image. Look at this nice asterism here of a ring of stars. A ring of stars, a ring of stars. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, maybe 11, 12, 13, 14, 15, 16, 17, 18, 19, plus some background stars, 20, 21, 21-ish in a ring there. Look how this one little splotch is like a dark blackout. So evidently there's some extra soot there or a dark nebula. Pier-Tech, welcome Vito. Here's a word from Pier-Tech. He built this, designed it, built it for us. We drove to Chicago, picked it up in pieces where he had disassembled it after building it. And we brought it down to Louisville and reassembled it. Not only the observatory, the roll-off roof observatory, but also the adjustable height pier that the telescope itself is sitting on. All came from Pier-Tech, Vito, and we love it. It's amazing stuff, and it's letting us catch these views tonight. So Vito, thanks for your work. Here I had always thought that Vito meant you're going to cast something out, but in reality, Vito means smart, engineered observatories. Well, this is 4 minutes, and you're starting to see handwriting on the wall. It's just a beautiful glob of stars. This is already, we've already written about this. Let's run this again. 7814, Jen. Cool, great job. Nice to know how things come about, right? Let's go with sequencer next target. And run. Let's go slew to this. NGC 7814. (7814). A galaxy in Pegasus. Okay. Oh, Azray just did an image of NGC 185 at the end of August. Cool. We had a bit of a tough time getting started tonight. Our ZWO ASI2600 camera would not connect for some reason. And the USB 3 data just wasn't getting through. Uh-oh, are we gonna be settled down here? Enough? It's gonna be close. I don't think we were. We'll see what this looks like, but I think the first image is gonna be a little bit ugly. So maybe we need to make that 25 seconds of settle down time. Drum roll, drum roll, drum roll. Not bad. Neat. We can see we can already see dust lanes across the middle of this. So this is 7814, Caldwell 43. NGC 7814 is a spiral galaxy about 40 million light years away. The galaxy is seen edge-on from Earth. It is sometimes referred to as the Little Sombrero. That's, what is that? M104 is the normal sombrero? Yeah. NGC, and this is Caldwell 43. Oh, this is the other companion of that Whirligig, the Whirligig galaxy we saw a while ago. 7814, right. Almost exactly edge-on. Talks about how far away it is. Azray says he has a picture of it on his Astrobin page. Faint remote galaxies. It bears a curious resemblance to an electric arc between two pointed electrodes. It looks as if several thousand excited fireflies have taken up temporary quarters on either side of the galaxy's wire-thin dust lane. It's beautiful, isn't it? It's not a blazing sight in small telescopes. A little sombrero. It's really cool. looked like a little sombrero. Stu said 40 million light years away. Oh, yeah. The star field behind 7814 is known for its density of faint remote galaxies, Stu says. Oh yeah, look, there's another one right there. There's one. Kind of like that one Hubble star field that's just filled with galaxies in every direction, huh? Beautiful. That's just 4 minutes. Dark Meta, good to see you. Glad to have you here. The little sombrero. It looks sort of like a smashed hamburger. You know, that's been in one of those smashing machines that they use in some sub shops. Kind of, you know, compacted and roasted, toasted a little bit. Look at this little galaxy here, real close, edge on also. Quite a galaxy field. 7814. Smashed hamburger galaxy. Panini, that's it, Jen. That's exactly what I was looking for. It's been smashed in a panini machine. Okay, so there's our planetarium software. Let's open it up in that. Show chart and zoom in. There's 7814. So that must be IC5381 next to it. Quite an exotic little galaxy. Right here is IC5381. IC5381. We could see IC5381 nearby. Galaxies. Okay, save a scene. Next target is NGC 752. NGC 752. An open cluster in Andromeda. You can already see it right there in the middle, huh? It's beautiful. Looks like those Christmas lights again, C28. William Herschel discovered it, although Hodierna might have discovered it first, 1654. Large, coarsely scattered cluster of very bright stars, irregularly round, very rich, about 1/2 of a degree, like a nebulous star to the naked eye. This escaped Charles Messier's careful gaze, even though it's brighter than 6 magnitude. It's a noteworthy attraction. Wow. It's hard to tell where it stops and the rich star field starts. Unlike most open clusters, which are tens or hundreds of millions of years old, NGC 752 is about 2 billion years old. Stu has researched that the large cluster lies 1,300 light years away from Earth and is easily seen through binoculars, although it may approach naked eye visibility under good observing conditions. It's among the oldest open clusters known. Has 15 red giants, 49 X-ray sources. Those are probably all extraterrestrials. Very open. Hard to know the cluster's boundaries. No central concentration. Curiously double nature. Very cool. So 2 billion years old. At 2 billion years old, one of the oldest known open clusters. 1,300 light years away, according to Stu. Fun. 752, Caldwell 28. Save a scene. Refresh. The double cluster, NGC 869. NGC 869. Don't like the framing on that. Can we exit from this programming? Pause. Stop. And let's get this framing better. Is that the wrong direction? It is, isn't it? I'm using the little control arrows over here in SharpCap to try to center these two clusters more squarely within the frame. Okay. You know, really, I don't think we need to live stack this. This is beautiful the way it is. We'll just make sure the title is correct, and it is. This title is not. NGC 869, the double cluster, and Perseus. NGC 869. This is C14. I see. C14. So there are two of them, part 1 and part 2. One is 869 and one is 884. I think the one on top is 884, but let's confirm that. Plate solve only. Stu is saying donate via super chats. If we get Doug up enough coffee, he might stay up later and show us more. Stu, you're great. You're funny. Yep. 869 is on top. 869 is on top. That's this first one. So that's Caldwell 14.1, and 884 is here. 869 is on top. Omira says that 884 is a remarkable cluster, so that's the one on the bottom. Let's get rid of this now. So this one, he says, is remarkable. Very large, very rich ruby star in the middle. There's the ruby star. This one's large and rich too, though. Ignites the fire of imagination in a young skywatcher. This is a good story. There's a party going on in the sky every Christmas Eve, and it focuses on the double cluster and Perseus. This cheerful gathering of imaginary celestial family is one you won't find mentioned in any previous book on star lore. It's a celestial play I created at the age of 10. It sounds silly now, but it might make a good under the stars skit for children. The play begins at 8 p.m. when my eyes knock on the door of the northwestern horizon. If the night is clear, the door opens, and there, standing with perfect posture, is the matronly form of the Northern Cross. Dressed in evening gown in the Milky Way, she welcomes me with open arms. What is this? Omira is just making this up. Herschel is credited with discovering these objects, star cluster in nature. The combined glow has been known since antiquity. Hipparchus recorded them as a cloudy spot. Wow. One long-lived mystery is why Messier didn't catalog them. A lazy patch of light. Did Messier just miss them? The two clusters occupy a full degree of width. When the double cluster is seen from nearly 14,000 feet atop Hawaii's Mauna Kea, a distinct lane of darkness separates the two components. Boy, he writes a lot about them. Resides in the Perseus arm of the Milky Way. He sketched them. Two frozen ponds, cleared of snow for skating. Skaters' tracks can be seen, faintly etched in starlight within each circle. Sapphires, rubies, topaz, and diamonds burst out of treasure chests, mired in the black sands of a volcanic beach. And the Perseid meteor shower originates from here. Well, we're going to say here on 14.1, rich, filled with bright, colorful stars. Double cluster. One component of the double cluster. And then the other one will say basically the same thing. The other element of the double cluster, also bright and filled with colorful stars. Azray says it looks very nice in my 16-inch daub from a dark site. Stu says located 7,460 light years away, cluster's about 14 million years old. All right, we're going to save a snapshot. And let's head to NGC 246. NGC 246. $7,460 light years away. I have about a dozen, or actually 13, on the live stream tonight, and we've made good progress. We've been working on the Caldwell list, as you know, after spending about, I don't know, 8 or 10 nights on the Herschel list, the Herschel 400. This Caldwell list is a lot more exciting, isn't it? I hate to say that, but that's because the objects are more obvious, they're larger, they're brighter, kind of more impactful, aren't they? But that's why the Messier list is considered the 101, the Caldwell list that we're on tonight is the 201, and the Herschel 400 that we've been on is a 301, and then there's a Herschel 2, and we haven't started that yet. Let's get through the Caldwell and Herschel 400. This is the Skull Nebula. How about that? AKA the Skull Nebula. Stu says it's 1,600 light years away. Oh my goodness, I think I see it right in the middle. Look at that. Jen says, I missed you guys. I've been traveling on business for 2 weeks. So nice, second night home. You know, Jen, we missed you as well. I thought, maybe I should try to contact Jen and make sure she's okay. No, it's great. I love that. Continuity, getting to know people. Yep, Stu noticed as well. The Cetus bubble, also, according to Stu, known as the Skull Nebula. Roughly 1,600 light years away. Trade shows, love it, but long days and nights. All right, let's redo this color balance. just to make sure we've got the best we can. And then let's bring up the mids. It does kind of look like a skull. It really does look like a skull. Didn't we see this recently? Heard you talk about the Cetus bubble before. I don't know. I mean, I guess it's possible because I have heard people complain that in Deep Sky Planner that every once in a while you'll complete an observation of an object on one catalog, and then when you work another catalog, you have to complete the observation of that same object in the other catalog every once in a while. But I don't think that's normally the case. I think normally seeing it in one catalog is counted as observation in the other catalog, I think. But this is very unique, isn't it? I don't remember seeing this object. Very unique. This is C56. Boy, they're so much easier to find with those huge numbers at the top. Herschel observed this November 27th, 1785. He said 4 or 5 pretty bright stars forming a trapezium of about 5 arc minutes in diameter. The enclosed space is filled up with faintly terminated milky nebulosity. The stars seem to have no connection with the nebulosity. I think he was right. I think this is a 4 or 5 stars in the way of looking at this planetary nebula. It's a broken shell of gas centered on a 12th magnitude star. Where is the 5 arc minute wide trapezium? And isn't it strange he would write 4 or 5 pretty bright stars? Herschel does not say the nebulosity is centered on the 12th magnitude star. Instead, he says that the nebula fills the space within the trapezium. Round diffused glow behind 3 stars of similar brightness. A 4th was glimpsed, but the central star was not seen. Really? Would a skilled observer like Morales miss seeing a 12th magnitude star in an 8-inch telescope? You wouldn't think so. Huh. Several people didn't see the central star. The nebulosity is faint, Herschel wrote. I question this description of it as faint. It isn't small. It's 4.6 arc minutes, 60% larger than the Owl Nebula. So Omiro says it's a mystery. This is NGC 246, yes. I need to correct this title, don't I? NGC 246, the Cetus bubble. He writes more about this mystery. He thinks that some of these stars are like novas, supernovae, getting brighter. It's like it's changing its formation. There's an arcing swath of nebulosity north of the central star. Yeah. The two are separated by a dark void, yes. Boy, he writes about this in detail. He recommends spending several nights with the object. That central star is also binary. The entire universe is a mystery to me, Jin says. How powerful were his scopes? You're talking about O'Meara? Jin said the entire universe is a mystery. If you're talking about O'Meara, yeah, his were not. There were 4-inch aperture and just 100 power. This is 11-inch using electronically-assisted astronomy. He wasn't using electronic-assisted astronomy either. Boy, it really does look like a skull when you brighten it up there. It looks like a downward view, and you can see one eye socket here, and that's a little eye in it, and you can see one eye socket here, indentured, indented in the skull. All right, we better save exactly a scene. But that's a really interesting object, isn't it, for a planetary nebula. All right, we've got 4 minutes left. I guess we could take one last galaxy. Let's just take the highest one, which is Caldwell 23. It amazes me they found these objects without today's technology. Agreed. NGC 891. Let's go there. NGC 891. NGC 891. NGC 891. And it's a galaxy in Andromeda. It's just a galaxy in Andromeda. 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 Look at that. Isn't that interesting? Two pairs of stars that are at the exact same angle. And here's another pair and another pair. So 4 pair at the same angle. Where is this galaxy? I don't see any galaxy. Maybe we're zoomed in too far. Could be right here. Did we ever extend our... Oh, we're going to barely be settled, I hope. Barely, barely, barely. Yes. Just in time. We've got to extend that time to 25 seconds, I fear. NGC 891, a galaxy in Andromeda. This will be our last object of the night. Oh my goodness, look at it right there smack in the middle. Bam! Boy, it's really big. It's like another hamburger galaxy. It's another edge on, isn't it? Etienne says, wow, these are so much bigger, aren't they? We've been spoiled looking at those tiny little objects in the Herschel 400, and now these are huge. Another edge on, Stu says. This is C23. Like the sombrero, yes. But it's not the sombrero. It's known colloquially as the Outer Limits Galaxy. Oh, that's Twilight Zone. 31 million light years away. in long exposures made with great telescopes, the edge on spiral galaxy looks like a flying saucer pitching sharply through a city of suns. The galaxy's supernatural appearance was naturally befitting for the television series The Outer Limits, which fathered the vast science fiction genre we enjoy today. At the close of the show's 1963 premiere episode, The Galaxy Being, images of galaxies, including NGC 891, which impressed me most of all, ebbed and flowed with the pulsing rhythm of the show's haunting music. The episode's plot, about an inventor who uses radio equipment to turn three-dimensional static into a pulsing being from a distant galaxy, captured the imaginations of impressionable youngsters. Wow. That's why O'Meara has nicknamed NGC 891 the Outer Limits Galaxy. It has been well studied since Caroline Herschel discovered it more than 2 million years ago. It's tilted a mere 6 degrees. 40 members include this galaxy 31 million light years away out. Stu says 30. Unbarred. It's 110,000 light years wide, 150 billion suns of mass. It would probably look like M81 in Ursa Major. It compares to NGC 891. Hubble determined that NGC 891's nuclear bulge is smaller than that of, this is NGC 891. Smaller than that of NGC 4565. Seems to contain copious quantities of mystery matter. Resides in the galaxies. A lot of molecular gas. Quite a bit of research about this. It's not so insignificant. Imagine what it looks like through a telescope to an imaginary inhabitant in a world within 891. The galaxy being the outer limits. It sends us a silent message, imploring us to explore, reach out, and give thought to the mysteries of the universe. The outer limits. Appeared in the final scene of an episode of The Outer Limits. So O'Meara gave it that nickname, the Outer Limits Galaxy. To us, it looked like the sombrero, a bit squished. Well, Jen, that's nice of you to say. The perfect ending view. Stu says in 2005, due to its attractiveness and scientific interest, NGC 891 was selected to be the first light image of the Large Binocular Telescope. We can actually tune it just a little better here. And then brighten it a little bit more to capture our final image of the night. Well, this was a very successful night. We motored through. I wonder if we go up here to, let's save this first. Now let's go up to Observing Log, Session Browser, and count the objects we did tonight. I guess you got to do, sorry, I'm not used to this, observation browser. That's what we got to see. We did 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 objects, which is right on schedule. I had really hoped we could do 13, and we end with this one. Well, gang, thanks for being a part of this night at Emerald Hill Skies. We've been trying to make our way through the Caldwell List tonight, and we used as our guidebook the Caldwell Objects by Steve O'Meara and live research by our buddy Stu from down in New Zealand. Stu, thanks for your help. Thanks to everybody for pitching in. Stu, lucky to catch the stream, didn't receive any notification, glad to have been here. We'll try to do better next time, make a better notification. Thanks to everybody here, and thanks especially to God for making all these images so incredibly, these targets so incredible for us to look at tonight, be able to enjoy. I hope you'll stop back again. Be sure and subscribe to Emerald Hill Skies email list, which you can see at emeraldhillskies.com, and subscribe to the YouTube channel if you would, please, if you like content like this. And as always, if you do like it, please click that thumbs up. It gets it up in everybody else's windshield. When they search for things in YouTube, it'll be seen a lot more if you'll subscribe. Hope you have a great evening and get some sleep. Thanks for spending this time with us, and we'll see you next time on Emerald Hill Skies. God bless and good night.